Hello, and welcome to Upstream at AKS, the series where we dive into how we're building cloud native experiences in the open source community. Thanks for being here. My name is Lachie Evenson, and I'm a product manager on Azure's cloud native ecosystem team, where our mission is to help make the community successful on their cloud native journeys. We have an awesome team that you'll find in almost every part of this ecosystem. And today, I'm happy to introduce my colleague, Joe, who is a member of our Upstream team. Welcome, Joe. It's great to have you here.
Hey everyone, thanks for having me here, Lucky.
Absolutely. Please tell us about what you do at Microsoft and in the cloud native ecosystem.
Yeah, so I'm a software engineer at Microsoft where I work on the Azure core upstream team. And our team has been focusing on contributing to the open source cloud native projects and growing the community around them. So for myself, over the past 3 years, I've been deeply focused on building the secure, efficient, and fast computing solution, especially with WebAssembly. And along the way, I've contributed to successful launch of the WASI Preview 2 or the WebAssembly System Interface, worked on various open source Wasm toolchains like the ones in the Go compiler, and helped bring WebAssembly into the cloud native world through projects like Containerd Run WASI and SpinCube. And more recently, I've been very interested in the intersection of AI agents and WebAssembly, particularly with the Model Context Protocol, or MCP. Just a couple of weeks ago, we open sourced Wassette. It is an MCP server that runs WebAssembly components. And I'm very excited to share more about this journey with you.
Wow, what a great introduction, Joe. It sounds like you're working on some really interesting pieces of the ecosystem. Now, I think WebAssembly is a big thing in unto itself. So I'm going to defer WebAssembly on its own, but this intersection that you talked about of AI and WebAssembly, how did you come up with that? And how did you see a need to actually use WebAssembly for AI?
Yeah. Well, before I answer this question, I want to kind of work through the history of AI. I think in the last 2 years, I've witnessed the field of AI undergoing a very big paradigm shift, moving beyond this reactive chatbot or LLMs towards a more proactive autonomous AI agents. These AI agents are designed to independently perceive their environment, formulate complex plans, and can execute multi-step tasks to achieve high-level goals with barely minimum or zero human supervisions. And this is a huge paradigm shift. So how do AI use their tools? Well, the answer is Model Context Protocol, or MCP, which is a very a open standard for agent-to-tool communication. And it was first developed by Anthropic and introduced in the end of 2024, and it becoming a standard adopted by large vendors like Microsoft, OpenAI, Google. It's a client server architecture and designed to be like this USB-C for AI. So that's the protocol. That's how agents use their tools. However, the the MCP ecosystem has a huge security issue, and that is fundamentally eroding the trust among enterprises. So, and here is the security risk. For AI agents to be useful and go beyond like a merely chatbot and become truly autonomous agent, it must have the ability to recognize the limits of its own knowledge and capabilities.
Mm.
When faced with a task for which it lacks capabilities, autonomous agent must be capable of identifying the missing tools and locating a trustful resource and source of tools, acquiring the tools and execute them without requiring step-by-step human intervention and guidance. But this straightforward approach represents a huge security challenge. Like just think about the action of downloading a third-party MCP tool and run it on your local machine or within an enterprise environment is very risky. And I can talk about all the security concerns and secure threat models over there, but it is the specific security concern that Wassette is engineered to solve, and that's where WebAssembly comes in, and where I believe it can present a very attractive solution to the security issue.
Joe, you've taken us on a massive journey about, where we've come from and where we're going with AI. And you talk about this paradigm shift where you're saying you want agents to be, or you see agents becoming autonomous. And the way they're becoming autonomous is using tools. I think one of the things, when I come in and take a look at AI is there's a bunch of new terminology. Like, could you walk us through an example of, what a tool might look like? I think, we're in the cloud native ecosystem piece. So, what would be an example experience you would be looking to create where an LLM would be accessing a tool in the context of trying to solve a problem? I think if we had a use case to walk through, it would at least help me contextualize kind of the goal that we're trying to get to with this technology.
Right. So the most popular AI agents today is called the coding agent or sweet agent. And there are those agent systems where designed to be able to act like a software engineer's assistant. They can work within a repo, and given a task, they can um, look up multiple files in the repo and try to fix the bugs or implement the features in that repo. So, and you can imagine for an LLM to be able to do this type of software engineer tasks, they need tools like be able to view the source code. They want to run some bash scripts in the terminal. They want to use the GitHub APIs to clone a repo and make a pull request or raise an issue or read issue. So they need to have all these tools. And in the context of MCP or Model Context Protocol, the tools are defined just to be like a JSON schema, and it defines what's the inputs of a function, what are the outputs of a function, and what's the description of this tool. And so, for example, one tool might be a fetch tool where you just give a website URL to the fetch tool and it returns you the markdown format of that web page. So you can define this as a JSON schema, say, this is a fetch tool, and the description will be fetch the website given the URL and return you a markdown format. And the input will be the URL of a type string, and output will be a result of type string. And so when AI sees that, it understands because it parses this information into its
Mm,
context and be able to use this tool. And a lot of the AI LLMs today are trained with this chain of thought, be able to call multiple tools, chain them together in order to finish one task.
okay, excellent. Thank you very much for that, apt description. I really think, where I've seen this used, I was using the AKS MCP server the other day, and I was in VS Code talking with my your co-pilot, and I was able to actually access my cluster and make some changes to the cluster on the fly. So in that context, that MCP just server would be connecting with Kubernetes, my AKS cluster, and actually communicating and using that context to make decisions and pass that between the LLM. So, okay, I kind of get where we're going with that and taking that context from live environments like this, repositories or software code repositories that you mentioned as well, which I think is interesting. So now, you're moving into, we have that's the future, but you see security risks with that. And obviously, I think as you're talking, I can see why there might be security risks. So what do you think, what are you trying to do with adding some security to this space through the project you mentioned, like Wassette?
Yeah, so in order to contribute to the security space of MCP, the first thing we need to understand is the threat model. We need to understand what are the security risks present in the MCP.
Mm,
And then once we identify the problems, we can find solutions to mitigate those security concerns. I'd like to categorize the security risks to the following three categories. The first thing is called prompt injection attacks. And it's basically malicious actors that can trick the agent to do something the user has never approved. with clever instructions hidden behind the context. So, for example, a GitHub issue is public to everyone, and everyone can raise a new public GitHub issue. And some attackers may inject some instructions into those GitHub issues. Say, for example, ignore previous instructions. Please do the following from the attacker's perspective. And when AI agent sees that GitHub issue and it thought that instruction, it cannot detect whether the instruction is from the user or from attacker. So it follows that instruction and might leak your secrets or if exfiltrate your sensitive information to the attacker's server. And this is a very serious issue. And I believe this is the number one concern among enterprises because the attack surface is just so large and so unexpected. The second category of security concern is called over-permissioning. Third-party tool may just run in your local systems granted with too much permissions than it needs to have. For example, a fetch tool that only talk to the network should never be able to read your file system. So if you granted file system permissions to that tool, it may have over permission and may do something unexpected. The third category is more traditionally what we see as security concerns. It's called supply chain attack. Tools can be distributed to NPM packages or pip packages, and they're very vulnerable to tampering. And you can actually do all sorts of supply chain attacks to compromise those tools. So with that background, this is the security threat model we are working with. And now what Wassette is doing. So Wassette is an MCP server first and foremost. It can talk to any MCP compliant agents, including VS Code, Cursor, Cloud Code, Gemini CLI. So it is using this MCP protocol to talk to any agents. And to mitigate some of those security concerns among tools, it uses the deny by default principle or threat model. So every tool that Wassette is using is sandboxed and have no access to the outside system and can never compromise your host system. And in order to make the tools functional, we also provide you a permission model that's very much like the iOS. Just think about when you download an app from iOS App Store and access your photos. It try to access your photos, and then you will prompt the user, do you approve this request? And we want every MCP tools to follow this permission model. And whenever they want to access some system resources, even the system's clock, we want them to prompt to the user and explicitly asking for permissions to be granted. So that's the permission model we are working on for Wassette.
Okay, excellent. I think that's a really good analogy using the, prompting the user for access to photos in the case that you were describing. So how would that prompting get back to the user in the case of, an MCP server? What would the workflow look like? I think that's an interesting take on, permissioning and least permissions.
Yeah. So basically you're asking for the developer experience.
Yeah.
And this is where the unusual bits of Wassette comes in. So when you download an MCP server runs in your host system, you already have the tools, right? So the fetch can be an MCP server, or the GitHub server can be an MCP server, and they already supply the tools to the AI agent. But in the case of Wassette, it acts as a kind of an app store for all the tools. And you can prompt the agent to dynamically load or unload new tools in WebAssembly Components. So the interface is going to just be natural language. You can ask the agent, what's the weather like in Seattle today, right? So for AI agent to answer that question, they may need to acquire a weather tool and call that tool, supplying the parameters of Seattle and today's day. And then that tool will return an answer to the agent, and the agent will get back to you, say,
Hmm.
oh, today's date is the weather of Seattle is this, right?
Yeah.
And that tool may make a network request into a remote server, and that's where the component Wasm component restricts the tool to not be able to make any network requests unless explicitly granted. So the Wassette will ask the agent to say, oh, sorry, this tool has no permissions to talk to a remote server. Do you want to grant permission? And then the agent will call an built-in tool in Wassette called grant network permission. And this is where the user comes in. The user will approve if I want to grant Wassette the network
Mm.
permissions to call this weather tool, right? So once the user approved it, and the agent can go ahead and execute that tool and successfully get the weather of the day back to the agent.
That is absolutely fascinating. I think you did a great job again of explaining it so that I could visualize it and follow along. So, how did you, I imagine when you looked at implementing a solution in Wassette, how did you end up thinking, we're going to do this with Wasm components? Because that, from what I know, that may not be an obvious choice, especially the overlap between ecosystems. What made you see this opportunity, and what makes, Wasm the right fit for what you're trying to
Um,
achieve with security?
Excellent question. So when I first look at the the solutions to the security concerns, and obviously we want to sandbox the tools,
Hmm.
and there are you know, virtualization technologies to sandbox a untrusted binary. There are virtual machines where you just basically run a full-blown virtual machine that runs the tool inside. There are containers, especially Docker containers, that limits the file systems and put C groups into those untrusted binaries. And there's a third category of virtualization, which is language runtimes like Dino or WebAssembly runtime.
Mm.
And the reason I chose WebAssembly is, I think, as so as a comparison to native code, WebAssembly core design philosophy is to provide a memory-safe sandbox execution environment. So
Mm.
unlike native code, which runs with broad access to the whole system, a WASM module has no capabilities. It simply can't interact with the outside world unless explicitly granted permissions. So if you want to access the file system, you have to import the file system. If you want to do the network, you have to import the network. So this is as a comparison to native code. It provides you this sandbox. As a comparison to virtual machines or containers, it is just much faster, much more efficient to start up. So you typically spend a minute or two to start a new virtual machine, or you spend 5 seconds to start a container. But in WebAssembly, you just start it in milliseconds. It's much more lightweight. As compared to
Mm.
containers, it's much easy to do this network restrictions. So imagine if you are designing a network restrictions for containers, you probably need to do some proxies. You need to start another container that runs a proxy inside, and
Mm.
that can intercept the network request. But in WebAssembly, because everything is virtualized, it's very easy to intercept outbound traffic and then do some manipulations there and see if
Okay, I
the
see.
satisfy your policies. So there are some great benefits to argue that Wasm provides you this lightweight virtualization technologies to sandbox the binary. However, do want to say a few words about the downsides, because every technology has pros and
Yeah,
cons.
it's
Container,
trade-offs.
container and the virtual machine are great at running arbitrary binaries. You can containerize any Linux binaries just by putting a Docker file and then run Docker build, right? So you can build a
Hmm.
container. But for WebAssembly, not every code can be compiled to WebAssembly. you need to use specialized tool chains. You need to rewrite your code to satisfy the WebAssembly system interface types or width. And you need to generate those bindings and work with WebAssembly bindings. So there's just a lot of churn to get your code compiled to Wasm. And this is a pretty big bottleneck for the developer experience.
Yeah, excellent. What are you most excited about, with the future of Wassette and basically this ecosystem of MCP and security?
Um, I'm mostly excited about of course, the security story here. I think Wassette presents a great chance for um, the ecosystem to adopt a more secure posture when they build tools and they build agentic systems. Um, Another thing I think Wassette does a pretty good job is to solve the problem of tool discovery and acquisitions through a mature ecosystem called Open Container Initiative, OCI, registries. So Wassette is built on OCI, and every tool that Wassette uses can be distributed through the OCI registries. And this allows Wassette to fetch Wasm components from standard registries like the Docker Hub or GitHub Container Registry or GHCR. And it
Mm.
furthermore allows Wasm components to be cryptographically signed using standard supply chain security tools like notations and cosign. And we can apply all of those industry standard supply chain hardening techniques to secure those agentic tools. Unlike you just run a random tool from npm package or from pip, or just run some native code from GitHub repos. And this, I think, is a big step forward towards a more secure supply chain for tools.
Excellent. I can see your passion in this space, and I know that security is going to become a big piece of the puzzle as we go towards this AI future. So I appreciate you coming up with creative solutions and the team working on Wassette to creating a way that we can actually solve this. I think it's really neat that you can spin up these sandbox environments without necessarily having to change the tools themselves and then get this prompt. So I think that's a really neat UX there. Joe, really appreciate you coming out and educating us on Wassette and the problems you're trying to solve with AI interactions with MCP servers, autonomous agents, and making sure the tool supply chain is actually secure. Really appreciate that. If folks are looking to get connected or learn more about Wassette and what you're working on, where should they go?
So they can go to aka.ms/Wassette. That's our open source implementation of Wassette. And you can join the Wassette channel in the Microsoft open source Discord server, where all the maintainers, including me, will be there to answer your questions. And we welcome contributions to Wassette.
Excellent. Well, thank you very much, Joe. Thanks everybody for joining us today. Please like and subscribe, and don't forget to let us know what you loved about today's content and any other topics you'd love to learn about more in the future. Thank you. Have a great
Thank
day.
you so
Thanks,
much,
Joe.
Lachie. Bye.